In this problem, we are asked to write the equation in standard form. And before we start, a couple things. I want to go through how you'll know to recognize that this is a hyperbola. So let's go through why it's not the other conic sections. Why is this not a circle? In order to be a circle, the coefficient in front of my x squared term and y squared term, not only must they both match, they both must be positive. So because I have a negative here, this can't be a circle. Is this an ellipse? Well, in order to be an ellipse, the coefficients in front of the x squared and y squared must be different, but they still must both be positive. So because there's a negative here, this can't be an ellipse. It can't be a parabola because for a parabola, I can only either have an x squared term or a y squared term. I can't have both. So this is definitely a hyperbola, and the defining feature is I have a negative in front of one of these squared terms. Now, the important thing to understand here is not only is this a hyperbola, but this specific one is a vertical hyperbola. And the reason I know it's a vertical hyperbola is because the y squared term is positive. And that's actually very, very important. In the last example, you might recall the x squared term was positive, so that was a horizontal hyperbola. I need to understand that this is a vertical hyperbola because when I organize all my information, I'm actually going to put the y squareds first. Okay, so let's basically complete the square and put this in standard form. Remember, my first step is to take my constant and move it to the right. So this is going to be positive 132 on the right side. And I'm going to organize the y squareds together. So I'm going to have y squared minus 14y plus blank, right? But then I'm going to add a plus blank here, and I'm kind of off level here. I'm not in line perfectly. And then I'm going to have a negative x squared minus 18x plus blank plus blank. Okay, that's really off. Sorry about that. Okay, so let's write the first set of terms as a trinomial that I can write as a binomial squared. I'm going to take the negative 14, I'm going to divide it by 2, and I'm going to square it. That's going to give me positive 49. Okay, so I'm going to put a 49 on the left, and I'm putting a 49 on the right. And then I can write the trinomial as a binomial squared. So that's going to be y minus 7 quantities squared. Okay, now remember here, I have this annoying negative in front of my x squared term. So the next thing I need to do is I need to factor out the negative 1. So factor out the negative 1 and make this x squared plus 18x plus blank. Okay, now let me just recopy this. Now I'm going to complete the square with the positive 18x. So let's think. So 18 divided by 2 squared, that's going to give me 9 squared, which is 81. Okay. Now, what I'm really adding to the right-hand side is not 81. There's a negative in front of the parentheses here. If I were to distribute that, it would be a negative 81. So what I need to add to the other side is a negative 81. Okay. And so this step is crucial, right? In the hyperbola especially, you're always going to need to factor something out of this second set of terms. Okay, so actually, let me go back down here. I'm making kind of a mess. This is y minus 7 quantities squared. I'm going to keep the negative, and I'm going to rewrite this trinomial as a binomial squared. So that's going to be x plus 9 squared. Okay, if I go over here and I take 32 plus 49 minus 81, that gives me 100. Double check my math there. I think that's right. Okay, now in order to finally be in standard form, remember I have to equal 1. So I need to divide every single term by 100. So my final answer is y minus 7, the quantity squared, over 100 minus the quantity x plus 9 squared over 100 equals 1, okay? And because the y term is positive, this is a vertical hyperbola. My a squared is 100, A is equal to 10. B squared is also 100, and that's okay. That can happen. B is equal to 10. Okay, remember A is the distance from the center to a vertex. B is the distance from the center to a co-vertex. My center is going to be at the point HK, remember, okay? HK, this is actually going to be -9, 7, okay? Because this is really like y minus k squared, right? This is really like x minus h squared. So be careful, that's HK is my center, -9, 7. I hope you found that helpful. And in the next couple videos, I'm gonna do more of a mix of problems.